Hello everyone, welcome to my channel Dynamic Coder. So today we will be covering the second scenario. Okay, so the scenario number second is, for example, this is our Windows machine, okay, and which cannot be able to access the internet. Okay, so what basically the issue is. Okay, so let's get into it and we'll try to resolve it. Okay, so please watch this video till the end. If you really like the content, then please like, share and subscribe the video. Okay, so before any further delay, let's get started. So here you can see that this is my Windows machine where I considered it as LAN side, and the port 1 which has been the WAN side. Okay, port 2 is LAN side. Okay, so this is the basic topology, and we'll access the firewall. As first we go to show system. Okay, so you can see 10.140 is the IP address, HTTPS admin, we set the password. Okay, so you can see here that we can able to logged in to our FortiGate firewall. Okay, so here when we go to our Windows machine, we go to CMD, we type ping google.com. Okay, so first of all we ping Google DNS server as ping 8.8.8.8. Okay, so here you can see that the request timeout is coming as error. Okay, we cannot be reachable to Google DNS server. Okay, at the same time we go to FortiGate firewall and we go to our console, CLI console, and we type as packet sniff command. Okay, so let's start. Diagnose sniff packet, then question mark. So you can see that interface, so we are taking any interface. Okay, question mark. So it will ask you about the filters. So what we're going to do is that we're going to add ICMP. Okay, because we want that particular protocol because we are using ping, right? And you can add question mark also. So here you can see that this gives us the verbose. So the verbose about to get the print header of the packet and with the interface name is verbose 4. Okay, so we add 4 question mark. You can see sniffer count, how many count you need. We need 0. Okay, again question mark. You can see that it will give you the time. So under time you can see A is considered as universal time and L is considered as a local time. So we select local time. Okay, and press enter. So this is the basic command, and you can start continuing it with question mark so that you get to know what all next or what all packet details you need it. Okay, while packet sniffing. Okay, press enter. So you can see that the sniffer has been turned on. Now we go to our Windows machine and we allow continuous ping. Okay, so you can see here that we started getting the packet sniff. Okay, so you can see here that it gives us the local timing details. Okay, this is port 2, correct, because the packet is coming in via port 2, correct, inward direction. Then this is our LAN address, this is our Google DNS server, ICMP is the protocol and echo is the request. Okay, so you can see here that this is all echo request is going inside via port 2, but we are not getting any reply coming from the internet, right? So you can see here this is all request. Now we go to Windows machine and we stop the ping, and we can also see trace route. Okay, so the command for trace route is execute trace route question mark, so you can add the, so we add 8.8.8.8. okay, press enter. So you can, it will show us that there are 32 next hop maximum, 3 per hop, 82 bytes per second. So this is 10.2. okay, so 10.2 is basically this particular interface, okay, which is towards the internet or ISP we can say. So that's why you can see here that it reaches till 10.2. okay, but there is no destination or next hop written, like we are not getting any details in that regards. okay, so we also did the steps, okay, to check the DNS entry. okay, we also have the option to go to Windows machine to check the default gateway, as whether we are able to reach to the default gateway or not. ipconfig. okay, so 10.10.10.10 is the default gateway. Sorry, we go to ping 10.10.10.10. okay, so you can see here that we are reachable till this port 2, 10.10.10.2, 10.10.10.10, which is on port 2. okay, so which signifies that we are reachable to it. okay, now you can see under trace route that okay, we have stopped the trace route because we are not getting any next hop information. okay, any route information in that regards. okay, now the next step is we just debug the packet. okay, so for debugging, okay, so for debugging we start adding the command as diagnose debug reset, if there was any debug before, that's why. okay, again diagnose debug flow filter destination address, or if you want source address it's fine, but we know that we have only single host, that's why we are just adding directly the destination address. okay, DADDR. okay, is 8.8.8.8, which is Google DNS server. okay, now diagnose debug enable, correct, we are enabling it. Then diagnose debug flow trace, it started tracing, start till number, so just add 10. right now we are just adding it and press enter. okay, now go to Windows machine and try to continuous ping to 8.8.8.8. we go to Windows machine and we just stop as Control C. okay, and we just diagnose debug disable. okay, we should have to disable it. okay, press enter, so we have disabled the debug. Now what we're going to do is we just copy this, or else it's fine if we can get the details from here. okay, so just take a single one as this ID. open notepad for the better understanding, paste it here. okay, so here you can see that the ID which is provided by FortiGate is 65308. okay, the trace ID is 1. then this is the particular function which is run by Fortinet Firewall. then message as vdom, so vdom we didn't create, so this selected as root because we only have single vdom as virtual domain, so which is root. Received a packet protocol number 1, correct, which is of ICMP, correct. then 10.10.2 is our LAN address, means this machine IP address, correct. Now A.A.8 is the destination, this is the port number, this is the destination port number, this is tunnel ID 0000 from port 2. So our traffic is moving inwards via port 2. So you can see here that these all information which is provided by under debug command. Okay, so type is 8, code is 0, ID as 1, sequence number it's given as 19. Okay, now next it's given the same ID, trace ID, function number this, then message allocate a new session. Okay, so this is basically a new session, that's why it's written a message as allocate a new session. So FortiGate is providing us the new session ID as 0000302. Okay, so tunnel ID is written as 0. Again it's trace, this is the function name. Okay, now find a route. So now it's allocating the session. Now the next scene is that it is looking for a route. So what basically the route is basically it search inside the firewall where they can able to move the particular packet towards the destination. Okay, so it is looking for the route, correct. Then it shows the gateway as 10.2. okay, so till here it shows that our gateway is 10.10.10.2 via port 1. Okay, so traffic needs to be go out, okay, via and reaches towards the next hop, which is the gateway to from our firewall. So from our firewall the gateway is 10.10.10.2, like this particular interface IP address. Okay, now the next is ID, then trace ID, this is the function name, forward handler. Okay, then message it's giving as denied by forward policy, check the policy number 3. Okay, so here it shows that there is a policy which is denying, okay, the reach of this particular host towards this to get the internet or to reach towards the Google DNS server. Okay, so we get the information in that regards. Okay, now we just check the policy. Okay, so we go to policy in object, go to firewall policy, and here we can see that this has been written as bytes also. So the traffic is particularly ping on that particular like the particular policy has been triggered. Okay, due to which we got this much number of bytes. Okay, the packets. Now click on it, click on edit, and here you can see that there is a policy where the incoming traffic port 2 from port 1, from port 2 to port 1. Okay, the source MAC address is 50.0.0.0.0.3.0.0.0.0. okay, so to recheck it, just go to Windows machine and type ipconfig/all. okay, which gives you all the information. Now check for the physical address. So physical address and MAC address are the same addresses. Okay, so here you can see the description, then physical address. So 50.0.0.0. so this particular MAC address has been blocked by the user on the firewall. Okay, so you can see here that this is the same MAC address. Okay, then the action is allowed as deny. So this traffic which should be deny, and the policy has been enabled. We just disabled the policy and press OK. So here we have just disabled it. Now the traffic which directly hits to land towards the internet, because we have disabled the policy above it, correct. So just go to Windows machine and try to ping 8.8.8.8. Let's wait for a while. Diagnose, sniffer, packet, any. Okay, and we use ICMP. You can see there is again the request coming, but there is no revert back. Okay. Okay, so here you can see that we cannot able to reach. Okay, again. Now again troubleshoot it. That what basically the problem is. Now go to our firewall again, console, and again add the diagnose command. So diagnose, debug, reset. Okay, now diagnose, debug, flow, filter, destination address is 8.8.8.8. Diagnose, debug, enable, diagnose, debug, flow filter, start 10. Okay, now you can see here that it gives us the debugging packets. Go to Windows machine, go to CMD, Control C. Okay, we have stopped the packet. Now again copy those packet. These are 11. So let's understand from here that this is the ID, then the function. This is the packet has been received. This is the source and destination. Okay, port 2. Okay, then sequence number 75. Now resolve the tuple, finding an existing session. Okay, so why it is telling us to find an existing session? Because the session has been created, okay, before, so it is just looking for the existing session that we have created. Okay, so again message. Now go to, this is the function message, enter the fast path. Okay, so why it written as enter the fast path? Because while we were discussing about the packet flow, there are two paths. If there is new session, then it enters to the slow path, and if the session was already there, then started looking inside the fast path, and then under fast path it will look for the route. Okay, then policy, and then all the security profiles, and then allow or deny will be then it will move the packet like that. Okay, so that's why it's written as fast path. Okay, now the next packet as the same information, receive the packet. Okay, then it gives us the same information, sequence number is 76. Okay, now finding an existing session, please enter the path. Okay, so this is all the same information. Now again, so which means that there is no issue in terms of any policy, right? So the issue of policy has been resolved. Okay, now go to firewall policy. Okay, and edit. Okay, so here if we can see the policy, then LAN to internet. Okay, then port 2, which is our incoming interface, correct? Outgoing interface, source, destination, everything is just action as accept. Now you can see here the NAT. Okay, so the NAT has been disabled. We have to enable the NAT. NAT is network address translation, right? So which has been disabled. Just, and the policy has been enabled. Just click on OK. Okay, now again go to Windows machine and just try to access. So right now you can able to see that your packet has been reachable towards the internet, and you can get the internet, right? Now Control C, I just stopping it, so I want to show you the packet flow. Okay, So you can see this is the ID, correct. The function name, allocate a new session. Okay, it is asked to allocate a new session. Okay, then another, finding a route. Okay, so the route has been, it gives us, it tells us that like the firewall is looking for a route which is to reach towards the internet. Okay, it gives us the default gateway is 10.2, correct, via port 1 as I discussed before. So next line you can see finding source net. So you can see here that this is the source net where our private IP address which is translated to the public IP address, right? So it gives us, this is our private IP address, okay, from the IP pool, okay, which gives the port number. Now destination NAT, okay, which is 10.129 port 0 fixed port. Okay, so allowed by the policy 1, so it gives us the information that this policy is allowing, okay, the packet to reach to the internet. Okay, then network protocol unit hook 4, then source net again 10.2 which needs to be translated to 10.129. okay, so 129 is basically the virtual IP which I have set, that's why it gives 129 as IP address. Okay, now receive a packet, so 10.2 reachable to the internet. Okay, so now we just want to look at the source net where our packet which needs to be reachable to the internet. Okay, as simple as that. So like by end of this video, like these are the basic problem which, but I advise that most of your issue will get resolved using debugging command. Okay, so just check step by step, follow proper packet flow, that how your packet flows, so that you can able to identify that what is the next step and what was the next step until when your firewall followed it. Okay, so this is the way you can see here the bytes of the packet is also increases to 11 kbps. Okay, because we are only allowing the ping packets. Okay, last time I also want to show you that the internet has been reachable. Okay, we are reaching towards the internet. Okay, again if we go to ns lookup www.google.com to get the IP address of Google. Okay, so you can see here it gives us the IP address, so we ping 142.250.203.228. sorry, we have entered the wrong, it's 142.250.203.228. so you can see here we are also reaching towards the google.com. okay, so we are getting internet. Okay, and guys, thank you so much for watching the video till the end. Okay, and please subscribe my channel if you really like my content.